Welcome back, ladies and gentlemen. Now we will begin the technology session 5, Sustainable Marine Transport. First of all, I'd like to introduce the moderator for this session. First of all, Professor Dr. Georg Erdmann, ICEF Steering Committee, retired chair of the Energy Systems Faculty of Process Engineering, Berlin University of Technology, President of the Board KSP Energy AG, Berlin. And Mr. Vikram Singh Mehta, ICEF Steering Committee, Chairman, Center for Social and Economic Progress Research Foundation. And now I would like to ask to Professor Dr. Erdmann to moderate this session. So please take the floor.
Thank you very much. Welcome to the session on sustainable marine transport. We have, in the last ICEF meetings, each time one session on transport systems, electrical vehicles, battery electrical vehicle, fuel cell electrical vehicle. Last years we had transportation by air. And this year we follow this series with sustainable marine transport. It's clear all these technologies are needed to reduce the greenhouse gas emissions. And today we try to understand where we stand in the development of clean marine transport in the world. We have 4 outstanding speakers for this session. In the order they will speak, Kawakita-san, sorry, he is from NEDO, project manager of Green Innovation Fund project. And he will probably explain us the strategy of NEDO. The second speaker is also from Japan, YOKOYAMA, Tsutomu-san, sorry. And he is executive officer of a shipping line NYK. And he will probably tell us about the most advanced ships he has in his fleet. The third speaker is online, is Selma Brynolf, sorry. She is a researcher from the Chalmers University of Technology in Sweden. And I think she will talk about her academic work. And our last speaker also comes from academia, Shu-Ling Chen. And she is director from Center of Marine and Logistic Management, Australian Maritime College, University of Tasmania, so really far in the south. Also, she's associate professor at the Australian Maritime College, University of Tasmania. So thank you very much for your presentation, and we will first go to Kawakita-san. Kawakita.
Yeah. My name is Kawakita. Kawakita. Yes, sorry, okay. Yeah. Georg-san, thank you for my introduction. My name is Kawakita from NEDO. Today, I will show you this title. Yeah, at first, I'd like to explain the current status of the energy transition in international shipping. CO2 emissions from international shipping account for 2% of total emissions, and it's ranked within top 10 largest emitter if it were a country. Since heavy fuel oil is the primary fuel, energy transition is essential for significant GHG emission reduction in international shipping. At present, ships using LNG and methanol as bridge fuels are beginning to operate. In the future, expected to shift from heavy fuel oil to zero-emission fuels, such as ammonia and hydrogen. The adoption of strategies and regulations in international shipping is discussing at the International Maritime Organization, IMO. The IMO adopted the 2023 IMO GHG strategies on reduction on GHG emissions from international shipping. This strategy set the goal of GHG net zero by around 2050. It also set intermediate targets of 20 to 30% reduction on total and annual GHG emissions by 2030, and 70 to 80% GHG reduction by 2040 to 28 levels. It also set a target of 5 to 10% uptaking zero or near zero GHG emission fuel by 2030. In October 2020, Japan formulated the green growth strategy through achieving carbon neutrality in 2050. This strategy has developed action plans for 14 primary priority fields. Now, Green Innovation Fund creates about $20 billion budget for 40 fields for continuous support up to 10 years. One of the 40 fields is shipping. We are promoting this project for the world's first practical use of zero-emission ships. This total budget of our project is $250 million. In this project, we will develop and demonstrate the engine, fuel tank, fuel supply system, and other components for next-generation ships, and develop the infrastructure for ammonia fuel supply to ships. The hydrogen and ammonia fueled engine required advanced combustion control and fuel injection technology. The fuel tank and fuel supply system require space saving, structure optimization, and material optimization. The measures against methane slips require development of technology to reduce the unbound methane contained in the exhaust gas from an LNG ship. This figure shows the development target for our Green Innovation Fund project. Our project targets ocean-going ships and large domestic ships that transport large volumes and long cruising distances, and small domestic ships. For more engine power and long cruising distance, it is necessary to develop hydrogen and ammonia combustion engines. In our project, a consortium companies from shipbuilding industry, the marine industry, and the shipping industry is working together. In the development hydrogen fuel ships, we are working on the development of marine hydrogen engine and fuel supply systems, aiming for commercial voyage after 2030. For consortiums working on development of ammonia fuel ships, development of ship with ammonia fuel domestic engine will be introduced by next presented Yokoyama-san of NLK. All of these projects aim to be in commercial voyages in 2028. In the Preventing Methane Slip on LNG fuel ships project, we are developing methane slip reduction technology from LNG fuel ships by catalyst and engine modification. And we'll start a demonstration voyage this year. All projects are progressing almost as planned. Finally, I would like to share my view of future issues for the social implementation of next-generation ships. Now, the development of next-generation ships itself is progressing well, but the issue clean fuel cost reduction and fuel supply chain development. It is a chicken and egg problem. Which comes first, the clean fuel users or the fuel suppliers? This figure shows the projected alternative fuel cost versus heavy fuel oil cost in 2030. Blue ammonia, 1.9 times, green ammonia and liquefied blue hydrogen 3.1 times, and liquefied green hydrogen 3.8 times. It's very expensive. So to solve the cost gap with heavy fuel oil, I hope develop global consensus on economic elements such as incentives and fuel charges and a discussion at IMO. Oh, thank you very much for my attention, for your attention.
Now going to the next speaker, Yokoyama-san.
Yes, thank you very much. My name is Yokoyama at NYK Line, Japanese shipping company. First of all, thank you very much for giving me this kind of opportunity to make presentation. First of all, let me introduce our company. We are a shipping company, own and operate more than 800 vessels, and which means most of the type of the cargo vessel they are under our operation, and we have a huge fleet. So therefore, we consume more than 3 million tons of heavy fuel oil, which means we emit 10 million tons of greenhouse gas, unfortunately, per year. So that's our challenge to achieve our target to realize net zero by 2050. This is our strategy. Any kind of effort to optimize operation, we are doing, we have already done, but that's not good enough to achieve net zero target. We have to change the fuel itself. So therefore, now we are promoting to use LNG as marine fuel. We are acting as demand supplier and also demand creator and supplier of the LNG as marine fuel. And we recognize the biggest candidate to achieve our net zero target is ammonia as marine fuel. But still, we are in the process of technical development and the development supply chain as marine fuel. So we expect on around 2030, we will increase the investment to build the vessel powered by ammonia. And then existing conventional oil powered vessel to be exited gradually. Although I mentioned ammonia is the biggest candidate, but we don't rule out any other solution like liquefied hydrogen or e-methanol or biofuel or battery as well. And recently we have an extensive discussion about onboard capture, onboard CCS. This is our strategy or scope of work. Our target, our strategy is to participate entire value chain. Obviously, the transportation part is our major chunk of our business, but we are very keen to participate upstream to know the pain point or constraint of the producer of the ammonia. And also, we intend to provide a bunkering business. Bunkering business means to sell the ammonia as marine fuel. And then for LNG, we have already realized we participate upstream, we transport, we sell the LNG as marine fuel to the various shipping company. And then important point is that we can contribute as demand creator. So in total, in the shipping industry, we consume 250 million tons per year, which is equivalent to the 500 million tons per year. I think we can recognize, encourage the upstream developers. This is our current activity. One of our activity, we proactively participate to develop the ammonia-powered vessel. Thanks to the Japanese government and the NEDO, we got a huge support, financial support. And then we formed the consortium with shipbuilder and the engine manufacturer and the classification society. And then we formed the 3 projects. One is to build the vessel tugboat powered by ammonia, already delivered. Let me touch upon later. And the next one is ammonia-powered vessel, middle-sized gas carrier. And the last one is a nitrogen dioxide reactor to remove the nitrogen. So all 3 projects is doing very shows a good progress, again, thanks to the NEDO and the Japanese government support. And then this is our significant achievement. 23rd of August, ammonia-powered tugboat has delivered, and then already start operation. This is purely commercial basis activity, not for the demonstration purpose. We see several demonstration projects use battery or use hydrogen, but this is purely commercial basis. This is world first. This is really proud of us. And already 2 months has passed. Close to 2 months has passed. She shows very good progress, and we are getting very confident. And then we would like to give a feedback to the latter part of development. And then tugboat is relatively small vessel, but this is not a matter of ammonia engine development. To operate the vessel, we have to complete the risk analysis because the ammonia is a highly toxic material. We have to complete full set of risk analysis, identify the risk, and then evaluate the risk, and then we also deliver the countermeasures. All kinds of things have to be completed, and then shipping company is in the best position to contribute to such area. So we have completed all set of such a preparation work and some setup or to comply the regulation requirement. That is also a big challenge because this is world first challenge. We have to clear any kind of regulation or challenge or requirement from government or authority. We have already set. And this is a small step, but without this first step, we can't move forward. And this is exactly the same what we have experienced in LNG. Many people talking about the fuel transition, but it's really difficult to participate in this fuel transition from supply and the demand side. But one of our strengths is that we have already done in the fuel transition of LNG as marine fuel. This is the last slide. And in order to achieve our goal, we need to work together with our external party. So therefore, this is very important player, our partner. One is a classification society, Class NK, and also GCMD located in Singapore, and the Maersk Mckinney Møller Center for Zero Carbon. They are major, very important player. We are working together to improve to achieve net zero as shipping industry. Thank you very much.
Our third speaker is online, Selma Brynolf from Sweden, Chalmers University. Please.
Yes, so my name is Selma Brynolf. I'm from Chalmers University. Are my slides up? It's just that I don't see them, or? Yeah, okay. So you have already heard about this net zero challenge that shipping have, and what I will talk about is 3 main pathways to decarbonization. I'm very glad to hear all the progress that is already made that we've heard from previous speakers, because this is the initiatives we really need to decarbonize shipping, I think. Oh, I didn't. So in the 3 energy transition pathways we have, we can start from the blue fuel pathway. We start from natural gas and use carbon capture to produce hydrogen. And then we can produce also ammonia or other carbon-based fuels if we want. And we store the captured carbon underground. The second main pathway is the biofuel route, where we can start from biomass, and there is a lot of different biofuel routes possible and a lot of different production pathways. In this study that I will present here, we have started from lignocellulosic biomass and gasification. And from this syngas that is generated, you can produce ammonia, you can produce hydrogen, you can produce liquid biomethane, and you can produce biomethanol. And the last of these main three pathways is the electrofuel route. And in this route, you start with renewable electricity and use electrolysis of water to produce hydrogen. And you need to combine the hydrogen then with carbon dioxide, which you can capture directly from air or from another point source. And then you can produce carbon-based fuels such as electromethanol, liquid electromethane, and hydrogen. And you can also then capture nitrogen and produce electroammonia. So what I will show is it's a comparison of these three main pathways, and all these pathways you can actually produce the same energy carriers that can be used in shipping. And of course, you can also use electricity directly, even if it will not be suitable for all ship types. So the study that I will present, it's called Role of Biofuels, Electrofuels, and Blue Fuels for Shipping, Environmental and Economic Life Cycle Consideration. And the main author is Fayaz Malik Kanchirala, and we published it very recently. So I'm going directly into the result. And what you see on this graph is the global warming potential in a 100-year time frame for a bulk carrier. So it's an average bulk carrier in the size of 25,000 to 49,999 gross tonnage. And you see the life cycle global warming potential. The green part represents the well to tank for the electrofuels. The yellow part represents the well to tank for the biofuels. And you see that for some biofuels option, it's negative because you capture carbon when the biomass grows, and then it's released when you use it on board the ship. And then the blue fuel pathways and the fossil fuel pathways are here, the blue parts. And on the right, there is the LNG and marine gas oil as a comparison, and also LNG and marine gas oil with onboard carbon capture as a comparison. And what we see is that the impact from fuel production is dominant in most cases when you shift to these new pathways. And traditionally for fossil fuels, it has been the operational phase that has been the dominant phase. We see that onboard carbon capture and blue fuels has limited potential over the life cycle. So there has a global warming reduction potential of between around 40 to 60%. If you go to the biofuels pathways that we assessed, they can reduce the climate impact even more, so around 50 to 78%. And for the electrofuel pathways, and here should be really noted that we used wind power to produce the electrofuels. And then you can have a really high reduction potential in the order of 60 to 85%. What you still see is the orange part is the production of the ship itself. So that also have an impact. And the purple part, it's the manufacture of the propulsion system of the ship. And what we also see in these studies is that for methane-based fuels, it's really important to limit the methane leakages and the methane slip. And I was very glad to hear then from the previous presenters that they're really addressing this issue from the industry. We also saw that if there is if ammonia is used in internal combustion engines, and there is a risk of these nitrous oxide emissions, and these are very critical for the climate performance of ammonia engines. Also, this was also then addressed by the previous presenter, so I'm very happy to see this development, and it's taking a lot of effort on that. So just to say something more about how the impact of the carbon intensity of electricity. So is in the pathway that I showed, the green pathway is the electrofuel pathway, and if you have wind power, which has very low carbon intensity, they have the lowest climate impact. But if we are producing it from the electricity mix, we know that we have not a very low carbon intensity of all electricity mix globally. And then biofuels or blue fuels could also contribute to a lower climate impact, depending on the electricity mix. So then I just want to sum up some concluding remarks from this study. And we see that biofuels can be important to decarbonize shipping, especially biomethanol and biomethane. It's important that we use a sustainable source of a biomass. And that's also a limited quantity available of sustainable biomass, and there is a competition from other sectors that might affect the biomass availability and the cost. When it comes to blue fuels and onboard carbon capture, they don't have the same carbon reduction potential as electrofuels and biofuels. So they cannot by themselves meet IMO 2050 climate targets without a significantly lowered shipping demand. Or they cannot really, because they cannot get to zero. And there is also a need for policy support. And when policy support is done, it needs to consider that these are short-term solutions. We might really need them in the short term, but they are not the long-term solution. And when it comes to electrofuels, they are very dependent on electricity prices and low carbon intensity of electricity production. And the high cost makes them less competitive in the short term. And we also saw from one of the previous presenters estimates about the cost. So thank you.
Thank you very much. Our last speaker is Shu-Ling Chen.
Yeah, thank you. First, thank you. Thanks for organizer inviting me flying from the down under to here. I'm Peggy Chen. I'm from Australian Maritime College. I think other presenters already mentioned. Actually, in future, maybe 2050, we will use mixed fuel for ships. So, but what's the implication for ports, maritime ports? Currently, we have a fossil fuel. We use LNG, and now ships move to methanol. But in the future, you could see on the right-hand side, ammonia, hydrogen could be the potential. So it's not only single fuel. It should be the mixed fuel for future. But when we look at from the port perspective, there are so many challenges facing this mixed fuel future. The first one is a safety challenge, and then the other is more the legal or policy side, and then the third one is logistics. So I will explain these three challenges. First, if you look at all the alternative fuel, actually their properties have some issues that may cause a hazard. You could see the comparison here, either flammable like hydrogen, maybe toxic like ammonia, methanol, even hurt human health. And even a liquefied hydrogen, you see the cryogenic temperature, and that's also maybe all the gas. There are a lot of risk inherited from all these alternative fuels. So that need port to consider how to manage those ships with alternative fuels. Also, we need to think about maybe those ships also carry liquefied hydrogen, carry ammonia as well. So you will see the picture in future ports very complex, and that is the issues we need to consider more. So ports need to consider how to mitigate those risks. And of course, the quantitative risk assessment is very important. We need to evaluate the probability and also the consequence of all the potential hazard and risk. And they need to think about how could we keep the saving zone or separate vessel coming in. Maybe even the container terminal line. I was in the Port Tanjung Palapas. You could see the 5 kilometer long the terminal. If all the container ship in the future coming in with different alternative fuel powered, then how much safety zone they need to keep distance, and how about if they can use a dedicated berthing area? If not, how far they need to keep distance? And also, do we have a detective device to monitor any potential leakage or flammable things coming through, and try to monitor and control all the risk? And how about people in ports? Are they trained well to manage all these different, fuel? And also bunkering. Yokoyama-san talked about the bunkering. And now LNG you could use a ship-to-ship. Of course, ammonia you also can. I mean, like in Dampier in Australia, they already implement on a ship-to-ship, the transfer ammonia, and that's what's successful. But how about when you do bunkering of all these alternative fuel, and you are still operating other cargoes, and this is all the risk, need to be considered. And do we have a good emergency response or for all these potential risk happening? And that's why all the strategy require a lot of policy or things too. So for the IMO, they already put this alternative fuel for ships, like ammonia is already entering guideline, but hydrogen is still under development. But for ports, the port state control inspections that we need to ensure the vessel owners or operator following the international regulations. And then for ISO standard, because that's really operating those alternative fuel in maybe handling, but there's still some gaps over there, although LNG and hydrogen is somewhat already done, but methanol still under approval process, and ammonia still have gap in the preparation. But if all this international regulation can be done, then that may help port to do some policy or the protocol development. So from the national perspective, the permit is very important, and also the environmental impact caused by all the hazard from alternative fuel, and the work and health safety regulation, and importantly, the post protocol for managing all these alternative fuel power vessels and even cargoes. And the pure complete audit is very important for the safety control. The final challenge I want to mention is the logistics challenge, because I think the other speaker mentioned about if a vessel come into the port with different alternative fuel power vessel, and like Singapore is very congested, how do we really ensure that we coordinate vessel arrival to prevent traffic congestion and reduce the risk of accidents? And especially in a bunkering operation, how do we really limit some access to certain port area during the bunkering operations? So this is one thing. The other is a fuel supply chain issue. I think that's come back to the chicken and egg issue. So how do we really ensure even poorly operate, these kind of, they can accept all these vessels with different fuel, but do they have, sufficient, fuel to support all these vessels? And that's also another issue. And port need to a lot of infrastructure, either retrofit or the new development, even store the fuel, or maybe there could be the hydrogen hub or ammonia hub or methanol hub for the future alternative fuel, or maybe the cargo. So the port infrastructure development also very costly, and that's also another challenge for ports. So sum up my presentation today is that from the ships to the port, because ship-shore interface, ports are very important for the whole hydrogen supply chain. But there are so many challenges, in front, either accepting ships, using a different fuel, or they may be the cargo, the facilitator. And these three really rely on maybe the more international collaboration, or the national collaboration, or regional collaboration. Thank you very much. That's my presentation.
Thank you. This was really a very comprehensive set of presentations. You all, four of you, summarized very clearly 3 or 4 issues. Of course, it's imperative that we decarbonize the shipping sector. The opening remark was that it accounts for a very substantive part of the global CO2 emissions. I think an earlier presentation said 3%. You all also very clearly established that there is a mosaic of technologies that are available. Some are available and some are in progress, but technology will probably not be the major constraint to decarbonization. But what will be a constraint, and that was also identified by all 4 of you, are a set of challenges. And those challenges could be regulatory, it could be related to safety, it could be infrastructure, it could also, of course, be related to the demand side. And then underpinning all of that is therefore the institutional framework. And that's where I wanted to just focus a question. Maybe I start with you,
Call me Peggy.
Yeah, sorry, excuse me. Because you raised two very important points. One was to do with the port and the need for the ports to actually create the infrastructure. Now, I was just going to ask you whether there is any move in your experience, are there any move to bring about a sort of coalition of ports across various countries or across various entities? And in that context, is there an effort to actually create a cross-sectoral consolidation of entities that are working on these issues, which combines the owners of ship owners, the manufacturers, the government, the port owners, and so on and so forth? So is there any evidence of this move to address the challenge that you talked about, regarding the port and the port infrastructure?
Yeah, thank you. I think you probably know Australia actually is a potential hydrogen exporting countries. So all the hydrogen hubs along the port side, the 6 major hydrogen port. So I'm from Tasmania, even Tasmania is a hydrogen port. I think we already collaborate with like the Netherlands, Port Rotterdam, Bremen, Germany, and even Japan, and about all this, the potential trade. But in the meantime, they also collaborate with Australian ports, really, for example, for the safety zone design. And also, they also, like a Port Rotterdam, also help different ports in Australia doing the, like ammonia, spillover or leak or something. This is a safety zone and also this safety assessment. So that's currently already, ongoing. And I mentioned that just a few weeks ago in Dampier, in WA, the Western Australia, we collaborate with Singapore and also Japan. I think it's MMOL. They do the ship-to-ship, ammonia trial. If that bunkering happening in ports and how to do that. So I think we already start doing that. Even we haven't really start producing all this ammonia or hydrogen yet, but I think that's already quite advanced. And a lot of port professionals or port managers, they already step ahead on this way to collaborate. That's my understanding in Australia.
And if I may just ask a question to you, Kawakita-san, because you were the only one who actually talked about finance, and you raised the issue of green innovation. Well, you didn't say, I think you used the word Green Innovation Fund. So can you elaborate on that? Because in the context of the session that we had earlier, this would be a very important factor, because I can't see how we can address some of the challenges that this issue confronts unless we actually also build up the institutions for financing, whether it's the infrastructure or for scaling up the production of the fuel, and building up a sort of cross-current of demand to incentivize the development of these new technologies.
Yes, Green Fund Innovation is not a fundamental study. The purpose is to develop the commercial-based technology, I think so. So Green Fund Innovation use this and NYK-san or something so to develop this ammonia fuel engine or hydrogen fuel engine. So technology process is now very good. Successful, I think so. So next issue is that I see the not shipping to bunkering or supply chain is very important, I think. And most problem is the cost of the alternative fuel is very high. So many green fuel user growing up. So maybe fuel cost is down. So I hope to grow the user side or the supply side. It's my opinion.
Vikram, maybe I just add one point on that, because we talk about all the, because I think technology won't be the issue. It's really the FID, the final decision making for the investment in hydrogen or other fuel production. I think in Australia, our new hydrogen strategy, actually, government already decide, okay, if you take the FID, then they can have a $2, subsidy, 1 kilo, if they take that and for the next 10 years production. So I think that's the way that we can speed up the production of the potential, the fuel that may help the shipping industry to really have those supply. That's just my amendment.
I have a question to Selma. In your study, you discussed the greenhouse gas reduction potential. Did you also consider the cost situation, and could you, if yes, explain us a little bit about this result?
Yeah, we have also considered the cost in the study, and it's and what we see is, I mean, then the cost will depend both on the production pathway. So if you start from electricity, or if you start from biomass or natural gas, but it also depends on the energy carrier. And when it comes to the energy carriers, it's typically ammonia that has the lowest cost, and also then for the electro pathways and the natural gas-based pathway, and we go the bio pathway, it's methanol that has the lowest cost. So it's a flipping between methanol and ammonia, depending on which pathway we are considering, but also hydrogen has a rather low cost, but it's the infrastructure for hydrogen distribution and is challenging, and the cost around that is uncertain. Can I just add on to the question about this ports, because also ports, I know that ports in Europe are, and you also mentioned that, Peggy, that Rotterdam port, but I mean, there is a lot of interest for ports to develop these new infrastructure in Sweden and Norway. Where ports are very active in testing out different alternatives and figure out how they can play their role in this transition.
No, I was just going to ask a question related to the timing of the development of ships, and Yokohama-san, you had talked about that, and you said, if I understood you correctly, that you expected the ammonia-led ships to actually come into, I don't know, operations by 2028 to 2030. So my question really, it is related to the previous question about infrastructure. Do you think that the development of these ships is going to be synergistic, meaning will it happen at the same time that the infrastructure that is required to be built in these ports will also come up, or will they be, are these two streams of activity not in sync?
Thank you very much. Very good question. From technical development point of view, I'm confident for vessel side and supply side. And then we see so many strong appetite of the developer of upstream. So in total, our industry is going to the very appropriate direction. Many people would like to participate in this entire new value chain, which has a huge potential. But I have to point out the one thing is I'm really afraid of the chicken and the egg situation, which we have experienced in the LNG. We built and started operation with the LNG powered vessel in 2015, small tugboat again. And then next year, we built the LNG powered 4,000 cars capacity big ro-ro vessel in Europe. And on the same year, we built the world first purpose-built LNG bunkering vessel. So we try to encourage or promote the LNG as marine fuel. But what happened later? It's really, really tough situation because no demand, no supply. Because as shipping company, we are very, very keen to build such a new vessel less carbon footprint, but we didn't see the sufficient bunker supply. As for the bunker supplier, we didn't see the sufficient vessel. So both sides hesitate to investment. So therefore, if we have some, we can see some kind of initiative to minimize such a chicken situation. If it works, I'm pretty confident.
I think to come to this point, maybe it is time now to make a technical decision. Which should be the preferred fuel in the future maritime transport? Because I don't think that all the ports in the world will use multiple in new infrastructures. They maybe select one or even maybe do two, but that's all. So is it the time now that we should decide on a global level, this international organization, to say we will go in this direction? Or do we have not enough information that we must still work on experimenting projects, etc.?
Maybe I answer first.
Yes.
I think because it comes back to the chicken and eggs issue, because even now we don't know, there are two perspectives. One is from ship owner's perspective. Cost is one issue. Second is the capacity of the fuel. So which fuel that will be produced more easily. And that's why, and the cost, so that's why I think in maritime industry, we all think about future should be multiple fuel. LNG currently, I think the order actually is increasing. It's very interesting, but this is the reality because that's easy and cheaper. So for the future to 2050, yes, technology we don't think is any issue. It's just like, can we decrease costs? I mean, like, yes, renewable energy, because we want to use green. So we don't want to use brown or even blue. So the green one, electricity, even Australia, we are developing the offshore wind. Someone said, why? You have so big land, but we need that in Tasmania, we need that to produce hydrogen. And even Tasmania is 100% renewable already, but not sufficient for producing that one. And that's why it's a cost. So when the cost going down, so I don't think IMO really can make a decision, okay, NYK use, or all the industry use this fuel. I don't think so. So I think the ports need to be ready for all the multi-fuel future. That's my view, yeah.
If I may.
From shipping company point of view, I don't think once we don't rely on one single solution, and multiple solutions to be simultaneously applied, like ammonia, hydrogen, e-fuel, biofuel, and onboard carbon capture. And we can use the conventional oil, but to purchase carbon credit. But one important item is scalable. Again, currently, shipping industry consumes 250 million tons of oil per year, which is equivalent to, again, 500 million of ammonia or 700 million hydrogen. Huge, anyhow. So e-methanol, that's not scalable because you have to rely on the capacity of the biogenic CO2. Obviously, we don't see a sufficient supply. So in terms of the scalability, currently we expect the ammonia is the best solution. But again, don't rule out any other solution. Type of the vessel, type of the operation profile of the vessel.
So Selma, you wanted to add something?
Yes, I mean, I agree, but I don't think we can decide on one best solution, because I also think what solution is best will depend on the ship segment and ship type. So for passenger vessels, we might not go for ammonia, for example. For some options, we might go for ammonia. And when it comes to scalability, I also want to say that actually all pathways are, or many of these pathways are scalable, because we can produce the same energy carrier from biomass and from natural gas, which will make the resource base scalable in a way. And the cost difference between those is then mainly between the energy sources. So I think all options are actually scalable. It's more cost and energy associated with capturing carbon from air if we need to do that. So therefore, methanol have a slight disadvantage, yes.
So I'm no expert on this subject, but if I was, so correct me if I'm making the wrong statement here, but listening to this discussion, it seems to me that in order for us to unlock the fuel that will most effectively decarbonize the shipping sector, we have to focus on three factors. It's the supply of feedstock, it's the technology, propulsion technology, and its safety. That's what Now, some technologies are already available. Some are available, but the feedstock is not available, or safety issues have not been addressed, whether it's toxicity or exposure to. So the question, I guess, for you, Selma, is your pathway, which from what I saw was a sort of a linear pathway, is that the way that we're going to progress, or is it what I thought Shu-Ling was saying was multiple pathways are going to actually be required, and at some point, all three key factors of success will come together and enable a company to unlock new fuels, presuming that the infrastructure, the bunkering infrastructure and the port facilities are in place. Is that argument too simplistic?
You know, we talk to the poor professional and then say they don't want to invest because they don't know what the ship owners will take. And you see, this is the dilemma. But how do we encourage? I mean, ship owners need to make decision, and then the producers, they need to make decision, and port need to look at, okay, what they are going to do. And that's all delay the progress. But I still believe that's the future. It's just sooner or later, that's it. But I think for maritime industry, need to prepare the multi-fuel future. That's for sure. Yeah.
Is that what Selma? Do you agree?
Yes, I agree. We will see more than one fuel in the future. We will not maybe see 10. I mean, also today, shipping has more than one fuel. We are talking about many pathways in the future, but we have the heavy fuel oil and the marine gas oil and the LNG today, and we might have some more options in the future in shipping, but we will see multiple choices. Yes, but not all options are equally good, so we might not see all of this what we have talked about.
Okay, that is a good conclusion, but I want to come back to this cost issue, and now I argue from a European point of view. The European authorities could put a limit of emissions for ships entering into European ports. And this would force all ship owners in the world to adapt, who want to come to Europe, to adapt to this standard. Would this be an impact? Would this have an impact on the disadvantage of costs? Because everybody has the same additional costs. Of course, the transportation of the container is more expensive, but everybody has the same higher costs. So where's the problem?
Yeah, but I think it's important with the price of fossil CO2 emissions also globally. So it's a very good start, but it's limited now in Europe, so that shipping is included in the emission trading system. And there is a lot of discussions ongoing at IMO on policy instrument also on a global level. And I think that will really be needed for this transition, so that it's not, because now you need to compete with the fossil fuels without they don't need to pay for their fossil CO2 emissions.
But I think currently they are talking about a pooling system. So if like NYK, they have one ammonia ship, that may be equivalent to maybe, because they can pool together, so maybe the other 64, fossil fuel vessel can be really, against that. So, but that's really encouraging the first mover of the shipping company to go in. And that's complying with the EU system. Yeah, so that's a short-term goal. But we don't want this delay. But of course, the EU will be more stringent on that. Penalty will in place in the future. But I think that's a good way for encouraging shipping company to move. Currently, they can really pull together, but later on they still improve and improve. That's maybe the policy side. Yeah.
Please.
Okay, this is a really big burden for shipping company because we have to have some additional burden. But fortunately, we have already operated so many vessels powered by LNG. So we select the vessel powered by LNG, and then assign the European voyage. If we have not such a fleet, it's really, really difficult. But another discussion we have, and then anyhow, shipping industry is not cash cow. We have to add such additional cost to the ocean freight. So therefore, eventually, let's say for the buyer of the car, Asian made by Asia, the European people have to bear such a cost. Final consumer have to bear such a cost. So that's not my problem, but I think we should recognize such a fundamental problem.
Kawakita-san, you would also add some point to this?
I don't know where it about the cost form, but my technology side, now our development engine is dual fuel engine. It means to use heavy fuel oil and ammonia or hydrogen. So if the ammonia or hydrogen, the cost is very high, ship owner use heavy fuel oil.
So this brings us to the end of our discussion. If I compare this discussion on maritime transport with the sustainable aviation transport last year, the maritime segment is much more advanced, and I'm more optimistic that we will have in the next 10 years a solution for cleaner maritime transport, whereas this seems to be a little bit more remoted in the airline business. You have given us a very nice inside view about the different aspects. It was a great discussion, listening to you. Thank you very much, and for your presentation. And please join me in applauding our auditorium.